Today we are discussing the sixth method of non-exact differential equation. So mdx plus ndy equal to 0 form is given and it is non-exact differential equation. Then suppose it is like this form, like x power a y power b, that means x power some constant y power constant into my dx plus nx dy, plus again x power constant y power constant into y dx plus x dy form. Suppose it is of this form where these powers and these all are constants like a, b, m, n, c, d, p, q are all constants. Then we are considering the integrating factor as x power h y power k. Now take this equation. Now see one problem. Suppose the question is like this. Now first of all we need to check whether it is an exact differential equation or not by taking dou m by dou y and dou n by dou x. See here, when you are comparing m value is here and here n value, then dou m by dou y with respect to y means 2y derivative 2, with respect to y means x is constant, so 6x constant, and y square derivative 2y, 2 6 are 12y, 12xy. Similarly with respect to x means here 3, with respect to x means 8y constant, and this is 2x, 2 8s are 16xy. So here both are not equal, that's why it is a non-exact differential equation. And also when you are seeing this question, what it will be like y dx plus x dy form. Here also y dx plus x dy form. Here x power 1 some constant, y power constant. So here we have 2, so multiply 2 with this term. Then here x power y power terms are not given, so we can write it as x power 0 y power 0 and take this term as it is, and x power 1 y power 1 here, 2 into this, that is 6y dx, like this we can multiply. Now it is like this form. So what will be the integrating factor for this? X power h y power k. Multiplied this integrating factor to the given equation, then what will it will become what? Exact differential equation. That's why we are multiplying this integrating factor to the given question. Okay, now x power h y power k into this term, and x power h into x power 1, h power x plus 1, h plus 1, and y power k into y power 1, y power k plus 1. Next, multiply for each term. Here x power h, there is no x term, so x power h 2. Here y power k, y power 1, y power k plus 1 into dx. Similarly we can take for second term. Similarly we can multiply for each and every term. Then again take dx common here, then first term, and here dx, then take this term 6 x power h plus a 1, y power k plus 1 plus 1 means k plus 2. See, now similarly we can do dy as common, then which is an exact differential equation. Why we can say it is an exact differential equation means we are multiplying the integrating factor to the given question, so absolutely it is an exact differential equation. And what we know, for any exact differential equation the condition will be dou m by dou y equal to dou n by dou x. So take this as some m1, this as n1, then find out dou m1 by dou y. With respect to y we are doing means 2 x power h constant here. This is with respect to y means x power n form, n into x power n minus 1, that is k plus 1 into y power k plus 1 minus 1 means y power k. Similarly here with respect to y means this is constant, and k plus 2 into y power k plus 2 minus 1, that is k plus 1. Similarly dou n1 by dou x, with respect to x means y constant here, and h plus 1 into x power h plus 1 minus 1. Here also this is constant, and h plus 2 into x power h plus 2 minus 1. Now these both are equal because when you are multiplying integrating factor to the given question, then it will become equal. That's why this equating these two values. When you are equating, then equating the like terms, that means here x power h y power k term is there, here also x power h y power k. So equating these coefficients, what will happen? 2 of k plus 1 equal to 3 of h plus 1. Then 2k plus 2, here 3h plus 3, make it as an equation in terms of h and k. Similarly we are taking x power h plus 1 y power k plus 1 terms here, take the coefficients as equal. Again we are getting one another equation in terms of h and k. By solving these two equations we are getting h and k values. So how to solve this? Just multiply. So multiply this equation with 9. So 9h minus 18, sorry, with 3, then 9h minus 6k equal to minus 3. Then take the second equation as it is. Then 6 gets cancelled by taking subtraction, minus plus plus here gets cancelled. Now you are getting h equal to 1. When you are substituting h equal to 1 in this equation, then you are getting k value as 2. So what will be the integrating factor? X power h, that is 1, y power k means 2 here. So multiply integrating factor to the given question. What will happen? X power 1 into x into y square, that is 2x into y square into y is y cube. Like this we can multiply for every term x into y square. Okay, and also we have, this is an exact differential equation, so we have the solution as integration mdx where y is constant and integration ndy where it is not having x terms equal to constant. We know this formula. And integration m1 into dx where take y as constant, y constant here, and do not having x terms. Here we have x terms, so we should not take this one. Here also we have x terms, that's why we should not take this term. Simply we can write as 0. Again y constant means 2y cube constant as it is, and integration x means x square by 2. Similarly 6y power 4 constant here, x square integration is x cube by 3. Then we are getting the required solution. See the next problem. Here also we are taking n values and find out dou m by dou y, dou n by dou x. With respect to y means this is 2y. With respect to y means this is constant and y derivative is 1. Similarly, dou n by dou x both are not equal means it is not an exact differential equation. Now what we have to change is we have to converting into y dx plus x dy form, right? That's why we are taking y common here. Then y dx plus 2x square 2x square dx. Then here also take x common. Then okay, first multiply all these terms, second term and first into this, second into this. After that take this term and this term at a time, like y common here from these two. Then what will happen? Y dx minus x dy will come, plus from these two x square taken as common, then 2y dx plus 2x dy. Now it is like which form? Y dx plus x dy. Here also y dx plus x dy. Okay, and here x power not there, so x power 0, y power 1 here. Okay, and here x power 2, y power 0 will come. So it is like this form. So what will be the integrating factor then? X power h, y power k multiplied with the given equation, multiplied to this total equation. Then what will happen? X power h into y power k plus 2, right? 2 into x power h plus 2, y power k plus 1 here, so k plus 1. Like this we can multiply for every term. Then it is an exact differential equation means this condition should be satisfied. Find out dou m by dou y. It was very easy, right? Because every term has x power h, y power k form itself, right? That's why directly we can take the derivative formula as n into x power n minus 1 formula, right? Dou m by dou y means x constant here, here k plus 2 into y power k plus 2 minus 1. Similarly here also, and dou n by dou x also we need to find, and it is an exact differential equation in the sense both are equal, equating both and equate the like terms. And what you are observing is here like terms should be there. Suppose here x power h, y power k, in the right side also x power h, y power k term should be there for any exact differential equation. Here also x plus h plus 2, here k, here also h plus 2 k. So like terms are there, equating these two terms, equating like terms. Now after solving these two equations you are getting h and k values. Then what will be the integrating factor then? Integrating factor equal to x power minus 5 by 2, y power minus 1 by 2 multiplied to the given equation, or else in the equation you need to substitute h and k values here. That means here substitute h value, k value in this total equation. Then it will become, right, take LCM 4 minus 1 3 by 2. Like this we can simplify this one. Again it is an exact differential equation which is of the form m1 dx plus n1 dy equal to 0, and the solution is this one, already we know that. So integration m1 into dx plus n1 into dy where not having x terms. Here we have x term, here also we have x term, that's why we can write here 0. So only here y constant means y power 3 by 2 constant as it is. integration x power n form it is. So x power n plus 1 by n plus 1, x power n plus 1 by n plus 1. Similarly here also equal to constant. Now simplify this term by taking LCM 2, then minus 5 plus 2 means minus 3 by 2 by 3 minus 3 by 2. Take this term into numerator, then it will become the answer. See this, here also we have x power h y power k, here also x power h y power k form, constant form, and here y dx plus x dy. So what we are doing is, first of all we need to check whether it is exact or not. Obviously it is not exact, that is dou m by dou y is not equal to dou n by dou x. Now we are changing into this form, then integrating factor will be this. So multiply x power h y power k to this equation, what will happen? 3 into x power h x power 1, that is x power h plus 1. Here y power k plus 2 into y k plus 3 will come. Like that we can multiply this with total equation. Then the equation will be like this. Now it is an exact differential equation, means find out dou m by dou y, dou n1 by dou x. After taking this, again with respect to y means x is constant, here y power n means n into y power n minus 1 formula. Then find out these both are then these both are equal. Equating these two terms, what will come? Like terms will come. Let us check. X power h plus 1 y power k. Here also x power h plus 1 y power k. So equating these coefficients, 3 into k plus 1 equal to 4 into h plus 2. Similarly we can equating like terms. Then we are getting two equations. Again solving these two equations, we are getting h and k values, right? Now substitute h power 1 k y power k means 3 here. Multiply with this, or you can substitute h equal to 1 here, k equal to 3 here. Then equation will be what? Like this equation will come. Like this equation will come, right? Here h equal to 1, k equal to 3, you are substituting here, then equation will come like this. Again dou m1 by dou x equal to dou n1 by dou m1 by dou y equal to dou n1 by dou x. So the solution will be what? So integration m1 dx plus n1 dy, where the conditions, here y constant, so 3 y power 4 constant, x square integration is x cube by 3. Here also 2 y power 6 constant, x square by 2. Here there is no terms without x, that's why we are taking 0 here into dy. So this will be the required solution. Similarly see this problem here also, first check whether it is exact or not. Again take the integrating factor, multiply to the given equation, then it will become in powers of h and k. Now what we have to do is, it is an exact differential equation that we need to consider, because we are multiplying integrating factor to the given equation, then it will become into exact. So what is the condition for exact? Dou m1 by dou y equal to dou n1 by dou x. Similarly we can find out these two values and equating both. Then equating like terms, x power h plus 2 y power k, here x plus h plus 2 y power k. Equating these both, again you are getting one equation in terms of h and k. Similarly for second like terms, again by solving this, hk values here we have big values here, k equal to minus 28 by 13, h equal to minus 49 by 13 after simplification. Again integrating factor is this one, multiply to the given equation or substitute h k values in the equation 1, then you are getting this equation. Again solution, again you are doing the same steps. Here also not having x terms are not there, so here simply we can write 0 here. Here y constant means only integrate this part, that is x power n, derivative is integration is x power n plus 1 by n plus 1. Similarly for the second term, which is the required answer for this. Similarly we have the same form, like by seeing the question we can guess it is in the form of y dx plus x dy like this. So you can guess that of sixth form, that's why we are checking the exact differentiation condition. Both are not equal, that's why it is non-exact in the sense. Integrating factor, again multiply here, same, when you are observing that same method but the numbers are different. So again we are equating dou m1 by dou y equal to dou n1 by dou x, then you are equating like terms here. Equating like terms, then h and k values will come. Here again substitute h and k values in the integrating factor and also in the equation, then it will become into exact. That's why the solution will be integration m1 dx plus n1 dy equal to c. Again in this we are taking y as constant, not having x terms are not there, that's why it is 0 here. Y constant means 4y square constant, x cube integration is x power 4 by 4. Similarly for the second one equal to which is the required solution for the given non-exact differential equation. See the last similar problem, ydx plus xdy, here also ydx plus xdy. So we can continue the process to check whether it is exact or not by seeing this. It is non-exact. Again, compare with this and take the integrating factor x power h k power k, y power k, multiply to the given equation. Then it will become like this. Again, it is an exact, so we are taking dm1 by dy, dn1 by dx, equating both and equating the like terms. Then you are getting two equations here. By solving this, you are getting h and k values multiplied to the given equation. Again, solution. Same method, and here also not having x terms are not there, so 0. Here y take as constant and simplify, then you are getting the required solution. So here are total 6 methods of non-exact differential equation. For this, first method is by derivative formula. Already we discussed in previous videos. See that videos. Derivative formula in the sense when the question will be of like x dy plus y dx, like that some formula are given to you. So according to that formula we need to substitute x dy plus y dx is given. Suppose then d of xy we should write, like that some formulas are there. Again take the integration, then you are getting the solution. That is the first method. And suppose the question is homogeneous non-exact differential equation is given. Homogeneous means every term should have the same degree, every term have same degree, then we can say it is homogeneous. In that cases we are taking integrating factor as 1 by mx plus ny. Similarly, suppose the question is in the form like function of xy into y dx, another function into x dy form. Suppose like this form is given, then the integrating factor will be 1 by mx minus ny. Now, when you are observing that mdx plus ndy equal to 0, suppose here it is in the form like mdx plus n dy equal to 0. The question is given like this. Suppose number of terms in m is greater than number of terms in n, then the integrating factor will be e power integration f of x dx, where this f of x can be written as 1 by n into dou m by dou y minus dou n by dou x. Already we discussed in the previous videos. Let us see. Similarly, number of terms in n is greater than number of terms of m, then what we can say, the integrating factor is e power integration f of y dy, where f of y can be written as 1 by m of dou n by dou x minus dou m by dou y. And in this video we discussed about the sixth method. Suppose it is like this form, then what will be the integrating factor? X power h y power k, then multiply to the given equation, then it will become exact. Then by equating like terms we are getting h and k values. Again take the solution for this. So these are some methods for non-exact differential equations.